we are going to build a 5-volt power supply. This is a very simple power supply, but it will get you started on your electronics lessons. The first thing I've got is a trusty voltmeter. It's actually a digital multimeter. I have any type of USB cord. We just want to make sure it has this, which is called a USB type A connector on one end. The other end doesn't matter because we're getting ready to take that off. Then you need any kind of USB charging device. I do want to express a little bit of concern here because the tendency is to plug this charger cable that we're getting ready to build into any USB port. That may or may not work in the future because charging devices are just charging devices. There's not any intelligence built in these. USB standards are changing so that when you plug this cable into a modern USB port, there's communications that goes on between the device and the port that determines what voltage to set that port to. Right now, those standards are only implemented in what's called USB-C devices. But the standard specifically says that charge-only devices do not run that protocol, and they always have 5 volts on them. That's the way it is right now. It's a bad practice in any case to plug this device into, let's say, the USB port on your computer. The reason I say that is because if you do something on your circuit and create a short circuit or create a high voltage pulse or something like that, it will go in and possibly damage your computer. Where this device, if you damage it, you're talking about a $3, $4, $5 device instead of a $500 computer. With that said, this entire device we're getting ready to build is not intended to be plugged into any USB port on any computer or any other device. This is strictly to be used with these little charging transformers. So don't try it. If you plug it in, you run the risk of damaging whatever you plug it into. The next thing you need is possibly some heat shrink tubing, wire cutters, and some way to strip the wire. I use a pocket knife. That's not the best thing to do. If you slip, you can cut yourself. It's best to use a proper set of wire strippers. Then I am going to use some of these flexible leads, jumpers, overhead jumpers that I purchased for use with a solderless breadboard. You don't have to use these, but it makes a really nice connection when we're done. So if you have these, you're going to need to sacrifice a couple of them because they will not, you won't be able to use them. They'll be dedicated to this power supply. You're going to need a female end and a male end if you're going to do it this way on both of these. I also choose a red and a black lead because the black is going to be for ground and the red is going to be for the 5-volt signal. In any case, that is all you need to build this power supply. We're going to start with the USB cord. It's going to have 2 ends on it. It's going to have the regular end like plugs into the charger. We're going to save this end. We're not going to cut it off. Then it will have another end. We don't know what this is. This could be the USB Micro Mini. It could be the A. There's several different connectors that go in here, but we're not concerned with that because we're getting ready to cut that off. I am going to just cut that off. Then I stripped the outer jacket off of the USB cord. There is shielding in there because this is technically a data communications wire. We don't need that shielding, so I'm also going to remove that. Underneath that shielding, you're going to see 4 wires. There's a red, a black, a green, and a white. We don't need anything but the black and the red. So I'm going to remove the green and white wires. Now we're just about done. Technically, you could use this as it is, but there's a couple of things I'm going to do. First off, when you're studying electronics, there's a couple of standards, and one of them is that black is ground and red has voltage on it. That doesn't hold for every place, but that's pretty much the standard for your bench. So what I'm going to do is I am going to take this connector, this jumper, and I'm going to solder it onto the red one, and I'm going to solder the black one onto the black one. You may think at first that we should have these ends sticking out with the pin and they'll just plug directly in the board. The reason I don't do that is because in electronics you have to be careful that you don't have a live wire sticking out here unshielded. Now we're only talking about 5 volts here, so it's not dangerous, but it's a good practice to always make sure that your live voltages are shielded or covered up. For instance, I'm going to actually use this to supply power to my board because I don't want it to accidentally touch a piece of equipment and create a spark. With this end on the outside, I don't have to worry about that. Plus, it has a nice little test point in there. I don't know if you can see it. I can't get my camera to focus. But right in there, you can use a voltmeter and touch right there to check your supply voltages. So I am going to hook the male end to this and to this, and then I'll have 2 ends that have plastic covering over them so they can't short anything out. You don't have to solder these. You can wrap them good and tight and use tape. I'm going to solder them because it makes a gas-tight connection that won't corrode and won't come loose in the future. If you're not comfortable with soldering yet, it's one of those things you need to learn, and now's a good time to learn it. It will just take practice. Plan on cutting things out and starting over a few times. So now I've stripped these wires down, given myself plenty of room to make a connection, and they're going to attach just like that. Here I have twisted these wires onto the pins of the jumper. I'm going to solder these, and they're going to be a gas tight rigid connection. If you're just going to twist them, don't twist them onto these pins. Cut the pin off, strip this wire back, and twist the 2 wires together, and you'll get a more reliable connection. Over time, those twisted connections are going to fail, but twisting onto a pin like this will not last any time. I mean, it'll break within a few days. So if you're going to just twist these without soldering, cut this off, strip this back, twist these 2 wires together good and tight, and then that'll be a longer lasting connection. And there, I've got them soldered. Then I just put heat shrink tubing over both of the connections, and we're going to shrink it down. And there, we've shrunk it down. The connections are all nice and isolated, so there can't be any shorts between these 2 where the bare wires were. Now, heat shrink tubing actually serves several purposes, but one of them is electrical isolation. So this is equivalent to putting black tape over that connection. But the good stuff when it shrinks, it adds structural strength to this connection here. So you may have noticed these wires here are very thin. Well, now this tubing is shrunk around those, so they're stronger. So you're not going to be bending that wire right at that connection and potentially breaking it. But we're going to add some more strength there, and you may notice the shielding here. It looks kind of ugly. We're going to clean that up. Generally, when you're working in electronics, you don't want wires like this exposed, because that can lay across your circuit or touch something and create a short where there's not one. So it's a good idea to just go ahead and cover that up. So what we're going to do is I'm going to put another piece of heat shrink tubing around here that's going to hold these two wires together and cover this up and add more strength right here, so the wire will not, this cord will not bend right there. So basically what I did is I put a larger piece of heat shrink tubing over both of those smaller pieces, and I encapsulated where the shielding was cut all the way back on the original cord. I covered up the entire connections, even though they were already covered and isolated. But what this does is this groups them together, and it makes that right in there is very rigid. It's way more rigid than the cord or these ends. So this is going to be fairly reliable. Notice that on the end, again, on this end, these are female connections, so we'll be able to plug pin headers into those. So now we are going to test our power supply. We're going to plug in the USB charger. We are going to plug in our modified cable. We are going to set our voltmeter down to 20 volts. And then we're going to check the voltage between these two leads. We'll measure the voltage between these two leads. By the way, these little connectors have a test point in there, so you can stick your voltmeter in there and you will see that we're getting 5.12 volts. The nice thing about this power supply, this cord modification, is if you do something that damages this, well, you can just throw this away, plug another one in, plug the cord in it, and you've got a 5-volt power supply again. When you're choosing this cord, you want to get as long a one as you need to get to your bench, so that you don't have to run an extension cord up here. On my bench, this would be plugged into the wall, and this cord would be 6 foot long or so that would reach up to my bench. And that way you don't have all this stuff on your bench. You just have a cord coming across to your bench. I chose this cord because the end of it was damaged, and I didn't want to cut up a new cord because I've already got a power supply here. And I don't really need this. This is just for demonstration in the video.